Hello and welcome back. I wanted to give you another challenge, another assignment. Obviously, this one's going to be all about arrays. I want you to get familiar with how to use an array, how to access an array, and how to create an array. So you should write a C program that's going to find all the prime numbers from 3 to 100. And we're going to do it very efficiently, so we're going to use a little algorithm that makes you use an array. But a very simple program. It's just going to display as output all the prime numbers from 3 to 100. And the reason you don't do 0 to 3 is because you're going to hard code those. It's pretty simple. First two prime numbers are 1 and 2, right? That are non-zero. So there's going to be no input to this program, just output. And the output's going to be each prime number separated by a space on a single line. It's pretty basic. All the way up to 100. You're going to need to create an array that will store each prime number as it is generated. You can hard code the first two prime numbers, which are 2 and 3, in the primes array. So what I'd envision here is that you would create an array, you would name it primes, and you would just hard code the first two in there. And it's important to hard code them too because the algorithm that we're going to use to find prime numbers is going to compare for any other prime numbers. And I'll explain that in a second. You want to utilize the loops for this assignment to only find the prime numbers up to 100. So right off the bat, you should envision a loop at least to display the prime numbers that you found. So that would probably be the ending loop, the loop at the end of your program that just goes through the primes array and displays everything that's inside there. Now, if you're finding all the prime numbers up to 100, you're not going to need to make the size of the array probably more than 50, because I don't think there's more than 50 prime numbers all the way up to 100. But you're not going to be able to set it exactly correctly because you don't know how many prime numbers there are. So I would say when you create the primes array, just make a size of 100. So you're definitely going to need a loop to print them out at the end. You're going to need another loop to try to find the prime numbers. And you can find the prime numbers any algorithm you want. But what I would use is I would use something like this because there's more reason to use an array if you do this algorithm. So the criteria that can be used to identify a prime number is that a number is considered prime if it is not evenly divisible by any other previous prime numbers. And there's also more to that algorithm, but that's the starting point. You also want to only look up to a certain number. So you can use the following as an X condition in the innermost loop. So again, what you're going to need to have here is you're probably going to need to have two loops. We already mentioned the third loop at the bottom, printing out the data. But you're going to need to have two loops for this assignment. And the algorithm that I'm discussing here is a more improved algorithm. So this is why you want to do it. Now, if you want to find prime numbers in a different way, that's okay, as long as you use an array, because the whole purpose of the assignment is not to understand prime numbers. It's to understand how to use arrays. By looking at the previously generated prime numbers, that forces you to use an array. And you'd store that each prime number as it gets generated, as I mentioned. And the other way that you can make it even more optimal is that you don't want to look at even numbers. So if you're going through each number from 3 to 100 and you're checking if that's prime, you can ignore the even numbers because even numbers are never going to be prime. So in the outermost loop or the innermost loop, you can check to see if the prime is divisible by the other primes, or make sure it's not even. You can check that and skip it. And then this other exit condition in the innermost loop is to make sure that the value of the p does not exceed the square root of the primes. That's the other part of the algorithm. So this might not make full sense, but basically these are some of the criteria that I want you to follow. Skip any checks for even numbers, and then the algorithm is to look for any previous prime numbers that were generated, and also to check whether or not p does not exceed the square root of the primes, because that's another way to check for a prime number. So you're going to need to have a for loop, which basically goes from 5 to 100. And then you can increment that by 2, so that you only look for odd numbers. And then in an inner for loop you have inside there, you're going to want to go from 1 until this other value, p divided by prime sub I, is greater than or equal to prime sub I. And you'll probably also want to make sure that the number is not prime. So you don't want to exceed a certain check, and then you also want to jump out of the inner loop if you actually found a prime number. And so the way that you can check for prime number, if your current number is divisible by any previous prime, so you can look at the primes array, and if the modulus for that is equal to 0, then you don't have a prime number. Otherwise, if you've done this whole check in this entire loop and you've got out of there with already exceeding the prime sub I is greater than prime sub I, the square root issue, and you not actually found a prime number, then that means that you can then add, you've actually never set it to false, you can actually add that prime number to your primes array. And then just print out the primes array. So the actual algorithm doesn't seem as confusing as I'm making it. Again, try to give you as many pseudocode hints there as possible with the outer for loop and the inner for loop. But you're going to need to access arrays, you're going to read arrays, you're going to look at an array to see previous values. It's going to get you really familiar with arrays. So good luck, and I'll provide a solution in the next lecture that will make a lot more sense. But these are the requirements and some hints. Thank you.